Today we are going to study the chapter ATA chapter number 29, which is hydraulics. Before I start teaching you, I want to ask you, what do you know about hydraulics?
It's a system that uses fluid, mostly I would say oil, to transfer
Oil. Transfer.
mostly
To transfer.
trans-
Completely.
energy.
So it is a system which works on oil to transfer. कुछ तो transfer करता होगा. Okay, I'll give it to you. Anyone else who would like to try?
Any system that uses any liquid or oil and apply मतलब compress it or apply pressure to move big parts या to operate a machine.
Correct. Sarvesh, anything from your end?
प्रेशर प्रोवाइड करता है उसको किसी भी मूवमेंट के लिए
So
टू
all
गेट
the
थिंग डन.
hydraulics, correct. ठीक है. So all of us are partially correct. I'm just going to make things very clear to you. Hydraulics is a means to move things which you humanly possibly cannot. Okay. A hydraulic system works on something known as the Pascal's law. Okay, I'll give you a little background. The hydraulic system works on something known as the Pascal's law. Pascal had to do with pressure. Pascal had to do with pressure. So, what it basically tells you is that, let's say if I have a water body which is inside confined inside any given closed space, the यहाँ पे हमारे पास एक fluid. Please do not call it oil. Please do not call it anything else. You will only call it hydraulic fluid. What is the difference between hydraulic fluid and what is the difference between hydraulic fluid and oil?
हाइड्रोलिक फ्लूइड्स नीड टू बी मोर विस्कस, मेल्टिंग पॉइंट ज़्यादा होना चाहिए, बॉइलिंग पॉइंट तो वो ऐसा टाइप्स होगा ना
Hydraulic
वो.
fluid is for hydraulic purposes. Oil is for engine lubrication. Oil is used for lubrication. Hydraulic fluid is used for hydraulic appliances and hydraulic pipelines. Both of them are different fluids. I'm making this very clear to you from the very beginning. Okay? No doubts? Great. So, अगर मैंने यहाँ पे एक सर्टेन अमाउंट ऑफ प्रेशर लगाया, लेट्स से मैंने यहाँ पे 20 हेक्टोपैस्कल्स का प्रेशर लगाया, यहाँ पर भी जो प्रेशर आएगा वो 20 हेक्टोपैस्कल्स का ही आएगा. इवन दो अगर मैं यहाँ पे जाऊँ और मैं एरिया बड़ा कर दूँ, इवन दो मैं यहाँ पर जाऊँ और एरिया बड़ा कर दूँ, ये बड़े एरिया के ऊपर भी प्रेशर उतना ही लगेगा. Pascal's law simply tells us for any given liquid in a closed system, the pressure throughout is constant, which means अगर मैं एक जगह पे एक एक्स अमाउंट ऑफ प्रेशर लगाता हूँ, दूसरी जगह वाई अमाउंट ऑफ प्रेशर नहीं आएगा, एक्स अमाउंट ऑफ प्रेशर ही आएगा, ना कम ना ज़्यादा. So this helped us gain mechanical advantage or mechanical leverage to move heavy things by applying a small force. Let's see how. Along with me, I want you to draw the following diagram. Pay attention. Let's say this entire thing is filled with some hydraulic fluid. ठीक है? Let's say this entire thing is filled with some sort of a hydraulic fluid here. ठीक है? आपने यहाँ पे आपके पास एक पिस्टन है, यहाँ पे भी आपके पास एक piston. I'll draw a better diagram, guys. I don't like this diagram. So let's have a look. Let's have a look. This is your hydraulic apparatus. On the both of these we have pistons. ठीक है? यहाँ पे you apply some sort of a force. Now, let's say you apply a force of 10 units. How much? You apply a force of 10 units. यहाँ पे एरिया कितना है? 1 मीटर स्क्वायर. यहाँ पे प्रेशर कितना आएगा? 10 Newtons per meter squared, which is basically 10 Pascal. Now, this same 10 Pascal will travel all the way through the system without any losses and will exert how much pressure here? It will exert 10 hectopascals of, sorry, not hectopascals, 10 pascals of pressure. But how much is this area? Is this area small or is this area big? This area is very big. Let's say this area is 20 meters squared. तो यहाँ पे फोर्स कितना लगेगा? प्रेशर टाइम्स एरिया. सो यू विल गेट अ फोर्स ऑफ 200 न्यूटन्स. यहाँ पे मैंने फोर्स कितना लगाया? 10 न्यूटन्स. यहाँ पे मुझे फोर्स कितने मिले? 200 न्यूटन्स. दैट इज द पावर ऑफ हाइड्रोलिक्स. बट यू विल से सर एनर्जी कैन नाइदर बी क्रिएटेड नॉट बी डिस्ट्रॉयड. सर वर्क आप जितना अंदर करोगे उतना ही वर्क इनपुट में करोगे, उतना ही वर्क आपको आउटपुट में मिलेगा. मुझे हाँ बिल्कुल सही बात है सर. यहाँ पे फोर्स कम, यहाँ पे फोर्स ज़्यादा, कुछ तो सर समझ में नहीं आ रहा. राइट. सो इसका मतलब क्या है? इसका मतलब ये बेसिकली यहाँ से अगर तुम मान लो 10 यूनिट्स नीचे जा रहे हो, यहाँ पे अगर तुम 10 यूनिट्स नीचे जा रहे हो तो तुमने जितना वॉल्यूम डिस्प्लेस किया उतना ही वॉल्यूम यहाँ पे ऊपर जाएगा ना. तुमने यहाँ पे जितना वॉल्यूम नीचे पुश किया उतना ही वॉल्यूम ऊपर जाएगा. सो even though he is pushing up with a greater force, he cannot push up with a very big displacement. His displacement will be small. So what is work? Work is force times displacement. My work done will be constant. So यहाँ पे you are applying a force of 10 newtons and multiplied it by a distance of, let's say, 220 meters. आप इसको नीचे 20 meters नीचे पुश करते हो. आप इसको 20 meters नीचे पुश करते हो. लेकिन जब यहाँ पे आपको फोर्स मिल रही है 200 न्यूटन्स की, राइट, व्हाट इज आउटपुट में, व्हाट इज वर्क? फोर्स टाइम्स डिस्टेंस. यहाँ पे आपको फोर्स कितनी मिल रही है? 200 न्यूटन्स की मिल रही है. लेकिन डिस्टेंस कितना जा रहा है? 1 मीटर. यहाँ पे फोर्स 20 टाइम्स कम लगानी पड़ रही है, यहाँ पे हमें फोर्स 20 टाइम्स ज़्यादा मिल रहा है. लेकिन यहाँ पे मुझे डिस्टेंस 20 टाइम्स जाना पड़ा, यहाँ पे डिस्टेंस मेरे को 1 ही जाएगा. Got it? So in real life, when we actually apply these hydraulics into applications, we do not really press this thing. Instead, what we do is we have something known as a pressure pump, an engine driven pressure pump or a constant pressure output pump of your hydraulics. Clear? Now hydraulics have two types of pumps. किसको note? Does anyone want to note this down? Anyone who wants to note this down, please make a note. Let me know. Now that everyone has noted it down, you can lower your hands and we can proceed to the next topic. The next topic, we will study about the two types of pumps that are there. Uh, there's one engine-driven type of pump, which is a constant volume output pump. It continuously supplies 10 liters per second, 10 liters per second, 10 liters per second. There is another type of a pump which is there, which is known as a constant pressure pump. So what he basically does is, let's say this is a pump and then there are many users. If there are many users, if there are many users, he will give you a higher volume of supply so as to maintain the same amount of pressure. क्योंकि अगर वो उतना प्रेशर उतना वॉल्यूम सप्लाई नहीं करेगा, प्रेशर ड्रॉप हो जाएगा. प्रेशर ड्रॉप हो जाएगा. However, if there are no users, he will not supply as much volume because नहीं तो ओवर प्रेशर हो जाएगा. So basically, this particular pump controls the output of the volume so as to maintain a constant pressure. There are two types of pump: constant volume pump, constant pressure pump. These are the ones that are used in aviation, especially in our Airbus A320. Okay, let's finally start with the chapter. Chapter number 29, hydraulics. What I want you to do is I want you to open your FCOMs, open chapter 25. Come on, go to DSC, go to chapter number 29. Under DSC chapter number 29, what are the two subtopics we have? We have descriptions and we have controls and indicators. Let's go through description. Now this chapter is divided into three parts: general, generation and distribution. ओके, जनरल के अंदर देख लो कुछ है नहीं, जनरेशन के अंदर बहुत कुछ है, एंड देन डिस्ट्रीब्यूशन में कुछ नहीं, एक टेबल. So that is the structure of your chapter. That is the structure of your chapter. Generation will occupy the biggest. Now, do not look at the FCON. You will only learn from my notes here. Pay attention. Leave everything. You can open your FCOM, relate to it from the very beginning. I want all videos on, please. Okay, let's start. Hydraulics systems are systems in their own whole. Okay? There is a tank. You take fluid from the tank. You pressurize it. So you have pressure available. Okay, wait. I also could give this pressure to an accumulator. So a tank, a pump takes fluid from the tank, pressurizes it, and then charges an accumulator with it. What is an accumulator? Accumulator is something like an electrical capacitor. It holds a lot of hydraulic fluid under pressure. Okay, and then you have the selector valves for all the different systems that are out there. Okay, so this is the general flow of the hydraulics. Then वो actuators का return line में fluid वापस आता है, मैं उसके बारे में तो बात करूँगा नहीं. That is return line. That entire circuit, tanki say pump, and then all the way down to the selector valves, accumulator selector valves, and then through the actuating jacks via the heat exchanger, and then we get back to the reservoir, hydraulic reservoir. That entire thing is one system. We have three such systems: left, middle, and right, said as green, blue, and yellow. It's just naming as colors. Their fluids are not of these colors. Green hydraulic fluid is not green in color, blue hydraulic fluid is not blue in color, and so on and so forth for yellow as well. How many systems do we have? Three. Why? Redundancy. Out of these three systems, which one is the biggest system? The green one, which is on the left, which is on the captain side. You need to understand, he's the captain side. How do you know that it is the biggest system? Because the capacity of the tank of the green system is 14.5 liters. The next in line is the right one, which is the yellow, that is 12.5 liters. Lastly, you have the middle one, which is the last resort, the backup, which is 6.5 liters. How do I remember it? I remember it 6.5 है, 6.5 है, इसका डबल करो 12.5, 6 का डबल 12 होता है, 0.5 तो ऐसे ही रखा, एंड देन इसमें से तुम दो ऐड कर दो 14.5. So this is a trick. Now, apart from that, pressurization source, one engine pump is there for the green. मैंने बोला था ना, टंकी से तुम फ्लूइड लोगे, उसको प्रेशराइज करोगे, कितने तुम्हारे पास पंप्स है प्रेशराइज करने के लिए? यू हैव वन इंजन ड्रिवन पंप. For the yellow hydraulic, you have one engine driven pump. Yes, good, no problems. So these two are the only systems which are driven by the engine, or the pumps by the engine. Okay, they do not work on electricity, they work on the mechanical output of the engine. Okay, but if the engine pump is not there, there is also an electrical pump. So if this will work even if electricity is there. Lastly, we have one hand pump. Now this hand pump cannot actually provide pressure to all the flight control surfaces that are there, the elevator that is there, and any other appliance. It can only and only provide pressure to the cargo door. So where is the cargo door? This is the aircraft. यहाँ पे और यहाँ पे कार्गो डोर्स होते हैं. बेसिकली यहाँ पे नीचे एक पैनल है, वो खोलते हैं, उसमें एक बटन रहता है, ओपन एंड क्लोज का. If the aircraft is electrically supplied, when you press that button, the yellow electric pump will start running and the gate will automatically unlatch and open. When you close, दबाओगे, वो automatically the yellow electric pump will get energized. Which will get energized? The yellow electrical pump will get energized. ठीक है? So now let's say if in this case the yellow electric pump or the aircraft is not electrically energized, does that mean that the guys below cannot open the cargo door? No, that's not so. वो जो बटन है, वो जो पैनल है, उसके जस्ट बाजू में आपके पास एक हैंड लीवर भी है, उसको आप ऐसे 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 करो, वो डोर खुल जाए. ठीक है? But then only the door will be supplied. We also have something known as a PTU. A PTU is a power transfer unit, a bidirectional power transfer unit. I'll teach you what a PTU essentially is actually. Okay? We are going to learn about the PTU at this particular section. Okay? Wait for it. Lastly, the blue system has one electrical pump and it has a ram air turbine. Now, ये जो पंप है, कांस्टेंट प्रेशर पंप, ये इंजन से भी ड्रिवन हो सकता है, तो इंजन ड्रिवन पंप है. इसको अगर कोई इलेक्ट्रिसिटी ड्राइव करे तो इलेक्ट्रिकल ड्रिवन पंप हो जाएगा. राइट? ये दोनों पंप्स जो है, ग्रीन और येलो, ये प्राइमरी वाले, सबसे बड़े वाले, तो ये इंजन से कनेक्टेड है. राइट? लेफ्ट इंजन एंड राइट इंजन रिस्पेक्टिवली. अगर फेल हो गया तो यहाँ पे इलेक्ट्रिकल पंप दिया हुआ है, एक हैंड पंप भी दिया हुआ है. दिस इज नॉट बेस्ड ऑन द इंजन, दिस इज अ बैकअप. Very few systems are powered by this and it's a very very small system. However, if both the engines fail, this is what will be available to you. Okay? Now because if both the engines fail, अच्छा चलो अगर दोनों इंजन चल रहे हैं, बट इंजन तो इसके शाफ्ट को घुमाएगा नहीं, इंजन तो यहाँ पे प्रेशर देगा नहीं, so you need an electrical pump for this. You need an electrical pump for this. Now let's say you don't have both the engines, so that means you don't have any electricity as well. So will this work? No. 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 Then in the last resort, you have something known as a ram air turbine. You all have been seeing and watching the ram air turbine. News about the ram air turbine, especially because of the Ahmedabad, unfortunate Ahmedabad incident that we had. So what is a ram air turbine?
It is basically a mechanical device which converts mechanical energy to electrical energy to supply the electrical units of the aircraft.
Okay. Yes, you're very close. You're very close.
Provides electrical as well as hydraulic. That's it.
So what will it provide mandatorily?
Electrical.
Incorrect. It will mandatorily provide hydraulic. Electrical is optional. That's why I asked you this question. Good, you learned something new. Now, the ram air turbine is a turbine. What do you mean by turbine? Have you ever seen a windmill? मेले में गए हो आप? Have you been to a fair? You get those घूमने वाली चीजें पेपर से बनी हुई, right? You place it in the front of air and it will rotate. Just like there's a turbine inside the jet engine as well. Push air through it, it will rotate, 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 rotate. And then you can use that rotation across the shaft. You can use it as कि हाँ वो shaft rotate करेगा, and then I can use that mechanical energy anywhere. Okay. Now, all these systems are designed to work at a pressure of 3000 psi, 3000 psi everywhere. The ram air turbine, however, has a limitation of 2500 psi due to again its own restrictions. Okay. Now let's see who are the users of all of these three systems. So what we did till now, for each of the hydraulics we have studied कि उनकी quantity कौन सी है, सबसे बड़ा system कौन सा है, and second largest, third largest. or the smallest basically. How what are the different sources of the pressurization of each hydraulic? So you have a two channel built-in redundancy here, two channel built-in redundancy here, four channel built-in redundancy here. सर टू टू फोर कैसे वन टू और थ्री होना चाहिए ना नहीं यहाँ पे पीटीयू भी है ना दैट्स व्हाई टू टू फोर नाउ talking about users or appliances which work with the help of this hydraulic. All the primary control surfaces, be it elevators for the pitch, ailerons for roll, and rudder for directional control. Also, you spoilers. All the primary control surface and the spoilers that is there, the usage of hydraulics is so exceptionally maintained कि यार all the control surface take inputs from all the hydraulics actually. They're so beautifully evened out or distributed out. Apart from this, the green engine or the green engine driven pump, the green system, uses that hydraulic fluid to actuate the reverses number one. लेफ्ट वाला हाइड्रोलिक लेफ्ट वाले रिवर्सल को चलाता है ठीक है राइट वाला हाइड्रोलिक राइट वाले रिवर्सल्स को चलाता है लेफ्ट वाला hydraulic which is the green hydraulic is used for normal braking right one is used for alternate braking and parking braking so there are three types of braking modes okay normal brake and alternate braking this can be with anti-skid this can be without anti-skid and then you have parking brake and to steer the nose wheel using the tiller on the ground you need yellow hydraulic let's say you have in any given failure let's say you have practiced dual hydraulic in your sims will you be able to vacate the runway if ever you have a green or sorry a yellow system failure no need to remember whenever you're also going for your sim checks if you have a yellow system failure you need to tell the atc on short finals or on finals sir we will not be able to vacate the runway due to nose wheel steering fault okay कोई doubt पक्का then other than these you have slats and flaps which are supplied by the green system slats by the blue and flaps by the yellow. Now, how do I remember this? See, the green system, if you can see, it is the most reliable system. Normal braking, which is used 90%, 99% of the time, is done by the left side, the green engine, the captain side. ठीक है कोई डाउट इसके बारे में तो मैं आता हूँ बाद में द ग्रीन सिस्टम एज लॉन्ग एज इट इज वर्किंग जो आपके सामने स्लैट्स हैं और जो आपके पीछे फ्लैप्स हैं वो दोनों काम कर रहे हैं so the forward slat is actually supplied by the green system. The backward flap is also supplied by the green system. But as a backup, the forward one is supplied by a blue system. The aft flaps are supplied by a yellow system. How do I like to teach it to you? B, Y, G. So B वाला आगे, yellow पीछे, G दोनों में. How do I like to teach it to you? Bring your girl. Okay, wait out. Same goes for rudder. Rudder में you have three actuators. Blue actuator, yellow actuator, green actuator. BYG. That's how you remember it. What is the full form? What is the full form?
Blue, yellow, green.
Yes, correct. It's not bring your girl. It's blue, yellow, green. वो सिर्फ याद रखने के लिए. Good. सही सीख रहे हो. Lastly, landing gear. The reason why this system is the biggest system is because of this landing gear. The landing gear is such a massive device, no man. The landing gear actuators are so massive. They take up so much of hydraulic fluid. I can't tell you. You know, When you extend the landing gear, it actually, when you see the reservoir quantity, it actually drops down by good 35%. Okay. Lastly, it is also supplying the emergen. Now, what is the emergen? The ram air turbine, when it deploys down, no? When the ram air turbine deploys down, it is rotating a constant pressure pump. It is rotating a constant pressure pump. So it is rotating a constant pressure pump, which is a hydraulic pump. तो ये जो पंखा है आपका, this is rotating a constant pressure pump, which is giving you hydraulic fluid. Now, this same shaft is also connected through an alternator, which is your emergen. But this emergen may be supplied, may not be supplied. यहाँ पे आपके पास एक कॉन्टैक्टर रहता है, इसके बीच में आपके पास इन दोनों के बीच में कॉन्टैक्टर रहता है. If that contactor is working good, emergen will be supplied. If that contactor is not working, emergen will not be supplied. Am I clear so far? So what is emergen? It is the emergency generator. What hydraulic supplies the emergen? Blue hydraulic. Any doubts? Okay.
I'm a little confused, Joe. You said that RAD will mandatorily provide hydraulic and electric would be secondary, but then why does it automatically deploy in case of Emerelect and इसमें manually करना पड़ता है?
Beautiful question. Beautiful question. समझ आया सबको क्वेश्चन? क्या क्वेश्चन है कुणाल?
ये हो रहा है मतलब इमरजेंसी मतलब इमरेलैक होता है तो रैट डिप्लॉय ऑटोमेटिकली बट इन द हाइड्रोलिक फेलियर वी हैव टू डू मैनुअली.
ब्यूटीफुल. समझ आ गया सब. Beautiful question. The reason I'm calling your question beautiful is no one from the last batch thought about this and put it across as this way. Okay, hear me out. This is the answer to your question. Okay, have a look. This push button over here is the rat man on push button. When you press this button, what will happen? The rat will come down. The rat ka shaft is physically rotating the constant pressure pump. The rat ka shaft is physically rotating the armature of the alternator. Are we clear here? No doubts? If you press this button, yes, you need to manually turn it on. You need to manually turn it on. We'll come to why manual. Okay, we'll come to why manual. But when this deploys, it is physically connected to the hydraulic pump. It is physically connected to the generator. But are you getting any output from the generator? No. You will only get hydraulic power as the output. Okay, I'll tell you why. दोनों कनेक्टेड है, दोनों घूम रहे हैं, लेकिन पावर सिर्फ हाइड्रोलिक है. वो इसीलिए होता है बिकॉज when you study about the electricity chapter, ये जो हमारा एमेचर, इट्स अ कॉइल, राइट? ये कॉइल को एक मैग्नेट के बीच में रखा जाता है, नॉर्थ पोल एंड साउथ पोल. ये नॉर्थ पोल एंड साउथ पोल सिर्फ परमानेंट मैग्नेट्स नहीं है, यहाँ पे भी इलेक्ट्रोमैग्नेट रहता है, यहाँ पे भी इलेक्ट्रोमैग्नेट रहता है, पोल्स के ऊपर इलेक्ट्रोमैग्नेटिक रहता है. So these coils that you see around the poles, these are known as field coils. In order for this armature to generate sufficient electricity, these field coils need to be energized. Understood? जब आप इसको दबाते हो, ये field coils energize नहीं होती, और जो भी थोड़ा मोटा करंट वो आर्मेचर से आ रहा है, उसका जो आउटपुट है, उसके आउटपुट में एक लिंक रहेगा, एक स्विच रहेगा, एक कॉन्टैक्टर रहेगा. क्या कहते हैं इसको? कॉन्टैक्टर कहते हैं. वो कॉन्टैक्टर इज नॉट कनेक्टेड. However, so now please have a look at this Emerelec. power panel. Can you see this man on auto button? वहां पे ऑटो लिखा था नहीं, यहाँ पे ऑटो लिखा है क्योंकि इसका एक ऑटो फंक्शन ये ऑटोमेटिक डिप्लॉयमेंट। और उसके बाजू में जो बटन भी है ना उसमें क्या लिखा है, रैट एंड इमर्जन। सो व्हेन यू प्रेस दिस बटन, द रैट विल बी कनेक्टेड एंड द इमर्जन की फील्ड कॉइल्स एंड उसका जो आउटपुट कॉन्टैक्टर है वो भी कनेक्टेड है। सो दैट इज व्हाई no matter what you do, you put this panel or that panel, wherever button you press, hydraulic pump pehle run hoga, emergen is optional. Now Krish, to answer your question, if my AC essential bus is not supplied, DC AC bus 1 AC bus 2 failure agar aapka ho gaya, if you have a dual AC bus failure, what is the problem? The problem is the AC essential bus is not supplied. AC essential bus is one of those buses in the aircraft that has to be supplied at any given cost. At any given cost. So in that case, it has to have an auto trigger. Now you need to realize that the aircraft that we are flying is a complete electrical aircraft. It's a fly-by-wire aircraft. If there's no electricity, there's no fly-by-wire computers, you have zero authority about of the flying control surfaces. That is why it's a very electricity dependent aircraft. If you have a dual AC bus failure, that means you have lost all the AC buses, buddy. You have zero AC power. कोई doubt? No? So, Krish, have I answered your doubt? Satisfied?
Yeah, satisfied.
Okay.
Thank you.
Now, the normal system pressure is 3000 psi and the fluid between the systems is non transferable. मतलब green system का जो fluid है वो green में ही रहता है, yellow का yellow में ही रहता है. Any doubts? Now, यहाँ पे मैंने आपको जो components बोले हैं, I want you to open your FCOMs and I want you to spend 5 minutes and go to 21 10 30. Go to 21 10 30. And under FCOM 21 10 30, you will come across a diagram, which is the distribution diagram. Okay? I want you to relate my diagram with that diagram and then tell me, did you like this diagram or not? Okay? Next thing I want you to do is I want you to look up something on PTU and priority valves. Okay? These are the two things that you have to do in this 5 minutes. I'll meet you in some time. Google use कर सकते हो, कुछ भी use कर सकते हो, but you have to give me answers on these two. What is the PTU and what are priority valves? See you in 5 minutes. Now, proceeding forward with the architecture, I want you to have your FCOMs open. Let us have a look at this architecture. You have the green reservoir. Now, as soon as the fluid goes forward from the green reservoir, it passes through the engine 1 fire shut-off valve. Now, this engine 1 fire shut-off valve takes command from the कहाँ से पे देता है? Take a guess. From the engine fire push button switch. Why? So as to secure the engine. Okay, and all the associated systems surrounding the engine, like the hydraulics, the bleed, the packs, and all of that. Okay, now this particular fluid that this goes through the engine one pump, and then it goes to the accumulator. What is an accumulator? Accumulator is a place where you can store fluid under pressure. Okay, so the fluid goes over here, and it is stored against the pressure over gas, and thereafter goes through its systems. And the same चीज यहाँ पर भी है. When it goes through the yellow reservoir से भी आपके पास दो चीजें parallel में चल रही हैं. पहली वाली है engine 2 fire shut off valve through the engine 2 pump, which is the same line as this. However, if the engine number 2 is not running, the engine 2 pump will not run, then fluid can be supplied via the yellow electric pump as well. There is a separate hand pump which is only for the use of cargo. It cannot supply the remaining systems. What is this particular thing out here? This is MPMP. What do you mean by MPMP? Motor and a pump and a motor and a pump. So now let's say if fluid is one, if this thing is working, the right hand side is working, the left hand side is not working, then how will it work? This will become the motor, this will become the pump. अगर ऐसे जा रहा है power, then this will become the motor, this will become the pump. So it's a motor pump combination. Lastly, we have the blue reservoir. The blue reservoir takes input from the yellow electric pump, supplies to the system. If the yellow electric pump fails, the rat. Now, what is the capacity of the rat? It can push 78 liters in a minute. Okay, uncommon question. Uncommon question. Now, based on this architecture, we are going to study a set of indications. Okay, Krish, you're laid back. Come forward. Come forward. Okay, I can only see this much. You're not slagging behind, right? Ah, this is better. Now, let's talk about the indications. This reservoir, there are only three indications in the reservoir, and we care about only three things. What are the three things? Which is the quantity of the fuel, the quantity of the fluid, which can be measured with the help of a level sensor, then the fluid temperature, lastly, the air pressure. These are the only three things that happens in a reservoir. You measure the temperature in a reservoir, and where do you measure the pressure? You measure the pressure downstream of the pressure pump. So, any reservoir fault will be associated with either of these three things. If the reservoir air pressure is low, if the reservoir fuel fluid quantity is low, or if the temperature is high, a fault light will come on. Now, which fault light will come on? This particular fault light will come on. The pump fault light will come on. Even though it's a reservoir fault, we do not have on the control panel, we do not have any button which is associated to the reservoir. Hence, it will come under a pump fault. Clear? So anything to do with the reservoir is because of this. Anything which is wrong with the reservoir means the entire fluid cannot be used. If there is low air pressure, that means there is air in the fuel, in the fluid. If the quantity is low, that means there is no fluid at all. And if there is a high fluid temperature, it is better not to use the fluid so as to prevent a burst of the duct, the hydraulic ducts canal, right? So now what we are doing is, so now resuming, now the fluid comes out and goes to this engine 1 to fire shut off valve, and then the engine driven fuel pump which controls the pressure at about 3000 psi. यहाँ पर क्या आएगा, कोई fault क्या हो सकती है, pressure low हो सकता है. So that's something that we look out for. You have a filter thereafter. Now then we have to have the accumulator. What is the purpose of the accumulator? As I've told you, it maintains a constant pressure. What do you mean by it maintains a constant pressure? देखो, अचानक से अगर यहाँ पे तुमने बोला मेरे को एलिवेटर ऐसे सीधा मेरे को अचानक से ऊपर करना है, तो यार ये पंप तो ऑलरेडी कट आउट फेज में चल रहा है, उसकी स्वॉश प्लेट पूरी सीधी हो चुकी है. The swash plate of the engine driven pump is at minimum stroke length. So, do you think that this entire system can instantly supply that chunk of energy? No, it cannot. That entire chunk of fluid will be passed on through the accumulator. The accumulator will push this fluid out into the system. In that split second, accumulator is basically it's a place where you've stored a lot of hydraulic pressure. ठीक है, तो वो अचानक से उसको डिलीवर भी कर सकता है. हाँ, once it has delivered it for about a second and a half, till then this engine driven pump will, the swash plate will go to the maximum stroke length and it will start giving you the pressure which is desirable by the system. Okay, so whenever the pressure demand is a transient demand, it will make sure that it will cater to those transient demands and maintain a constant pressure there. Yes, Krish, huge, ask. I can read you.
So, am I getting it right? Is it like to cover the lag for?
Yes, if I were to say
Oh,
it in a better way, it would be like there would be a lag between the second the aircraft has to move the control surface and the lag between the engine driven pump to actually provide that much amount of pressure. So that is where the accumulator steps in between. Okay, it's like a capacitor inside a tube. Any doubts? Any doubts? No doubts. Good. Then we have, it goes through the PTU and you have a pressure sensor. So there's nothing really magical about this. Now this entire schematic is shown on the ECAM like this. Look at this. So जो रिजर्वायर है ऐसा, वो रिजर्वायर ऐसा दिखाया जाता है. ये रिजर्वायर का नीचे वाला बॉटम क्वांटिटी है, which is basically the low, यहाँ पे नहीं होना चाहिए वो. It's the top quantity. It's the normal filling quantity. Okay. This is the triangle. Now this triangle goes down like this. ऐसा. अगर क्वांटिटी कम हो जाएगा तो ऐसे हो जाएगा. So it basically moves up and down. अगर नीचे डाउन हुआ तो ये ऐसे हो जाएगा. अगर क्वांटिटी बढ़ गई तो ये ऐसे हो जाएगी. So it shows the quantity like this. What were the other two things? Temperature high. So that's an overheat. यहाँ पे overheat in amber आ जाता है. And then we have low air pressure. वो भी यहाँ पे white पे आ जाता है. Crazy, right? Thereafter on the ECAM we have this valve, which is the shut-off valve, fire shut-off valve. We have the pump. Now this pump will have indications, which we are going to study. Anytime this is in line, it's good. Anytime it's cross line, it's not working. It's off. And then you have the PTU. Lastly, you have the system output pressure. This is the pump output pressure. यहाँ पे भी अगर आप जनरेट कर रहे हो प्रेशर, बट आप यहाँ पे पंप का आउटपुट प्रेशर देख रहे हो. What if PTU से आ जाए pressure? So you need to also measure the pressure downstream of the PTU. So this is the system pressure sensor. This is the output of the total pressure that is going to the entire system. कोई डाउट? सो ये वाला जो डायग्राम है, ये जो यहाँ पे खत्म होता है, इसके ऊपर आता है वो जो मैंने डिस्ट्रीब्यूशन डायग्राम बताया था ना. दिस इज द आर्किटेक्चर. इसके ऊपर क्या आता है? डिस्ट्रीब्यूशन डायग्राम. गॉट इट? कोई डाउट? Now let's go to controls and indicators. In the controls and indicators, this is the overhead panel. Now, something, let's talk about the overhead panel. Can you tell me what are the panels in the overhead panel in sequence from the top to the bottom? Firstly, of the fire panel, then
Fire, hydraulic, fuel, then electrical, then air condition, and below that, pressurization through window heat, then external integrated lights and
correct, absolutely correct. Let's have a look at it, shall we? As rightly said by Asmith, this is the fire panel. Just uske below, we have the hydraulic panel and then the fuel panel. Then we have the electrical panel, air conditioning, and then this entire panel, it has a lot of small compartments here. So on the left hand side we have anti-ice, middle we have probe window heat, and then on the right hand side we have the pressurization control. उससे और नीचे आएंगे. So you have, on the left you have external lights, on the right hand side you have internal lights, and then in the center you have the APU, the auxiliary power unit. Have I made myself clear? Any auto functions here in the hydraulic? Yes, the blue electric pump is at auto. What is the funda of its auto thing? As long as one engine is running, blue electric pump will run. PTU auto function, both differential pressure more than 500, both masters off or both masters on, or one engine master off, other is off. Well, one is off, one is on. You're not in the towing position, you're not in parking brake off. Okay? So if one engine master is on, the other is off, and the aircraft is not in towing position, and the parking brake is
Off.
off or not off.
On.
On. देखो क्या लिखा है, have a look.
Parking brakes off, chokes on.
That is not what the line I made. PTU will run. PTU will run if the parking brake is set to off. Okay, not off नहीं है, on नहीं. So basically, when you're taxing, मैंने क्या बोला? Think about it this way: the PTU will run when you're doing one engine taxi. When are you doing one engine taxi? When the towing lever is not in the towing position. Second is when your parking brake is off with one engine run. कोई doubt? No doubts? Pakka? Good. So now talking about controls and indicators, you have already seen the control panel that I showed you in the 360-degree cockpit. Please have a look. This is the overhead panel, and in this entire overhead panel, you can see these green lines. These green lines basically show the schematic of the hydraulic system. In this schematic, Kunal, I cannot see you.
भाई यहाँ पे वाईफाई की बहुत प्रॉब्लम हो रही है। मैं वीडियो ऑन कर रहा हूँ, डिस्कनेक्ट हो जा रहा है।
Okay, no problem.
अभी मैंने इसको मैंने बात की है अभी।
No
देखते हैं।
problem. So have a look. On the overhead panel, you have the engine number one pump, you have the engine number two pump. Both of them have the same indications that are not written anything about the engine two pump. What you actually need to know here is why does this fault light come? So it's a pump fault light. So pump low pressure is but obvious, which is the last one. Quite doubt? No doubt. Other than that, the three problems that are there with the reservoir. What are the three problems? Reservoir overheat, low air pressure, low fuel, low quantity. Low air pressure, reservoir overheat, low level. Okay, and the same will be for engine number two pump. Now, what other types of pumps do we have? We have the electric pumps. We have the electric pump. So be it this electric pump or this electric pump, दोनों की fault light will be the same, which is the same four things: low air pressure, reservoir overheat, low level, low pump pressure. But then, because this is an electric pump, it's not an engine driven pump. Because it is an electrical pump, the electricity can also cause heat. So because of this, we also have one more thing: pump overheat. In the case of a pump overheat, when is reservoir overheat, this is pump overheat. So here we had three problems of reservoir, one of pump. Here we had three problems of reservoir, two of pumps. Okay, so we have covered four buttons row: one, two, three, four. Now we are going to talk about the PTU. You know the operation logic of the PTU. Lastly, coming over here, talking about the fault light of the PTU. See, एक बात बताओ, अगर यहाँ पे मेरा इंजन नंबर टू का पंप फेल किया तो क्या पीटीयू की फॉल्ट लाइट आएगी? नहीं, पीटीयू की फॉल्ट लाइट तब आएगी जब पीटीयू नहीं चल सकता. अगर लो एयर प्रेशर है, अरे भाई पीटीयू तो उसी के लिए बना है. आई हैव मेड पीटीयू फॉर द एग्जैक्ट सेम रीजन दैट एट एनी गिवन पॉइंट ऑफ टाइम आई हैव अ लो प्रेशर हियर और आई हैव अ पंप लो प्रेशर हियर. माय पीटीयू कैन एक्चुअली टेक ओवर. So will the PTU fault light come on if there is a pump low pressure? No. Yes, but it will come on if there is low air pressure, low reservoir over anything that reservoir related problems. The PTU will have a fault light. Why? Because if you have low air pressure, you don't want to keep on using engine number two or the yellow hydraulic system because it is contaminated with air. Secondly, if it has low level, क्या खाली इंजन चलाओगे, खाली मोटर चलाओगे? नहीं ना, खाली मोटर चलाओगे क्यों? खाली मोटर नहीं चलाओगे. Lastly, reservoir overheat. You don't want to overheat the entire system. Okay. Where is the maintenance panel? So where is the maintenance panel? The maintenance panel is right here. Please have a look. This is the maintenance panel. ये देख रहे हो ऊपर, हाइड्रोलिक. टॉप राइट साइड पे, इधर, यहाँ पे दिख रहा है ना? Okay, so on the right hand side, this is the maintenance panel. So now we have the maintenance panel. Now we have the maintenance panel. In this maintenance panel, it is used to run the blue hydraulic system on the ground, which is the blue pump override. Okay, these are the leak measurement valves. Remember, I had shown you the leak measurement valves on the distribution wala thing. So what it does is basically it closes all of those valves. So the hydraulic pressure to the primary flight control surfaces, all of it stops, and it helps the engineering team to rectify and identify leaks and their locations. Have I made myself clear? Talking about indicators, please have a look. Let's have a look at the reservoir. This reservoir indications is something that we have studied already. कि वो कैसे up down होती है. This is the amber quantity, which is the low level warning, and this entire thing is the normal filling. ठीक है? Look at this. Low level warning, normal filling. Anything less than this is not normal. अगर low air pressure हुआ, then low air pressure will come here in amber. Overheat हुआ, overheat will come in amber. And this is very much self-explanatory. We have covered these three reservoir-related problems: low level, low air pressure, overheat. कोई doubt? Krish? Okay. Now we are done with this section of your ecam. Now let's see what is the next section of the ecam has to tell us. These two valves. These are the engine 1 or engine 2 fire shut-off valves. Here this is closed because the green system is not deployed. What is these? This is the symbol for a pump. Even when you study fuel, no, this same particular symbol will come into play. If the engine is in its normal position and it is running, it's like this. If the engine is in its abnormal position and not running, it's this. बेसिक इसका फंडा आपको बताऊंगा. ये देखो, अगर तुम्हारा पंप ऑन है और पंप का प्रेशर भी चल रहा है ना, सही सही, कोई दिक्कत नहीं. अगर तुम्हारा पंप ऑन है लेकिन तब भी प्रेशर नहीं दे रहा है, तो ये आएगा लाइक दिस. और अगर तुम्हारा पंप ऑफ है, so it will show up like this. Any doubts? So we are done with indications of this, this, and this. Next to these, how do you determine whether this is an engine driven pump? You will have the engine number written right next to it. If the engine number 1 is running at a speed which is above idle, this thing will be in white. But if the engine is below idle, this would be in amber. So as to indicate to the pilot, bro, it's an engine related problem or is it a pump related problem? So for example, so for example, अगर यहाँ पे this would have been the case, तो it's a normal working. But अगर इसी जगह मैं यहाँ पे कुछ ऐसा करूँ, ऐसा कुछ करूँ, so this basically shows that engine 1 is running normally. It is above idle. It is running at close to full power. But then also the pump pressure is low. So the pump pressure is low because of a pump fault. However, if the indication is like this, then I can very easily rectify or identify that the failure that is there of the pump is because of the engine. That is how it helps us differentiate between the two. Okay. The electrical pump can also get overheated. So यहाँ पे उसकी overheat. कोई doubt? Now, now, a few things which are not usually used, which is the ram air turbine and the yellow electric pump. The ram air turbine and the yellow electric pump. ये सारे कैसे indication? So we have done with everything over here. We are done with everything over here. अब इसके ऊपर का करें. The ram air turbine is like this. It's shown like this. Rat. यहाँ पे है। अब ये रैट दिखाता है कि नहीं? हमेशा। हाँ जी, ये रैट हमेशा दिखाता है। RAT वाइट में रहेगा हमेशा। अब जो खेल है ना, ये सारे ये ट्राइंगल का है। देखिए, अगर रैट स्टोर्ड है, नहीं डिप्लॉयड है, तो रैट और ये हॉलो वाइट ट्राइंगल दिखाएगा। अगर रैट डिप्लॉयड है तो जैसा अभी दिखा रहा है वैसे दिखाएगा। लेकिन अगर रैट डिप्लॉय हुई, लेकिन उसका जो हाइड्रोलिक पंप है, जो ब्लू वाला हाइड्रोलिक पंप है, वो पंप फेल हो गया, तो वो बोलेगा कि भाई रैट तो डिप्लॉय कर दी, बट ये मेरा एम्बर हो गया, पंप नहीं चल। कोई डाउट? यही चीज यहाँ तक भी जाती। जो ब्लू आपका हाइड्रोलिक सिस्टम है, इट मेंटेन्स प्रेशर टिल व्हाट PSI? The ram a turbine can provide how much PSI of pressure?
2500.
2500.
Correct. Absolutely. Absolutely correct. So we are done with this as well. We are done with this as well. अच्छा, यहाँ पे देखो, अभी तुम्हारे येलो इलेक्ट्रिक पंप का है। अच्छा, अब देखो, दिस इज वेरी ब्यूटीफुल ना। ये तुम्हारा पंप का इंडिकेशन है, ये तुम्हारी इलेक्ट्रिसिटी का इंडिकेशन है। सो दिस इज एन इलेक्ट्रिकल पंप कंट्रोल इंडिकेशन, दिस इज द पावर सप्लाई ऑफ द इलेक्ट्रिकल पंप। अब इसका मतलब समझो। लेट्स से ऐसा है, इज द पंप ऑन? नो, इट्स नॉट ऑन। दिस इज द पंप। Is the pump on? No, it is not on. So the pump is off. Now the pump is on. And the power supply is also normal. So the pump is on. This is the pump is on. This power supply is normal because this is in white. So the elect power is in normal. Look at this. यहाँ पे भी तुम्हारा pump amber में हो गया। मतलब तुम्हारा there is a problem with the pump का pressure. Is there a problem with the electricity? No. So the power is normal. However, अगर ये ऐसे रहता, so then there's a problem with the electricity. Pump pressure is low, but the pump has failed. It's nothing to do with the, it has nothing to do with the pump being bad. It has to do with the power supply failing. Any doubts? Lastly, what does this tell you? You tell it to me. आप सिखाओगे. Is the electrical power supply normal? Yes. Is the pump pressure normal? No. Any abnormal condition with the pump? Yes. Overheat. So same thing. Pump pressure is low. Pump is at overheat, but the power supply is normal. Understood? I've taught you each and every nitty gritty of this thing in detail. नाउ अगर PTU का भी देखें तो ये कैसे नॉर्मली रहता है। अगर ये काम नहीं करता है ना, तो ये कुछ ऐसे रहता है, hollow. This thing, this triangle again here and this triangle again here is a motor and a pump combination. Let's see how. अगर PTU तुम्हारा ऑटो है तो नॉर्मल ऐसे रहेगा, but there will be some procedures where will they ask you specifically to turn the PTU off. तो जब आप उसको ऑफ कर दोगे, एम्बर हो जाएगा। When the PTU is operational, then one of them will be the motor, the other them will be a pump. Again, this will be a motor and this will be a pump. Now, to show that these two things are running, you make the triangles solid. Any doubts? So that is the indications that the PTU can have over here. These are the final system pressures. These are the final system pressures. कितना प्रेशर कम हो जाएगा इसका, तब जाके ये सारे एम्बर में होंगे। अंडर व्हाट प्रेशर? 3000 तुम्हारा पूरा है ना, उसका आधा करो, 1500 होता है। 50 कम कर दो इसमें से, 1450। याद रहेगा? That is all actually about the chapter of hydraulics. That is all about the chapter of hydraulics. If I were to talk to you about memos to indicate to the pilot on the ECAM memo page, which is shown right over here, If you see a hydraulic PTU running like this, that means the PTU is running. If you see it on ground, that means you have to apply drains and you haven't done the yellow electric pump on as a part of your checklist. Okay. Lastly, whenever the rat has subtended out, the rat out message has to be displayed. Whenever the rat has come down, so it has to indicate over here that the rat is out. Any doubts? What am I going to do is